Hey there, this is JC. Welcome to my channel. Today we are going to talking about the airflow is suitable for you or not. Okay, Apache Airflow. What is Apache Airflow? So which is an open source platform designed to programmatically author, schedule, and monitor a workflow. It's a powerful and flexible tool used for managing complex data pipelines, automatic tasks, and orchestration workflows in a scalable and flexible and reliable manner. So here I have some detailed overview of the Apache Airflow. Dynamic workflow authoring. Workflow are designed as the directed acyclic graphs, aka DAGs, using Python, allowing you to use Python code to create complex workflows with dynamic behavior. Extendability. Airflow provides a rich set of the operators to define tasks and their dependencies, and it can be extended with the custom operators and plugins to suit specific needs. If you are not understanding about the extensible, so I will please watch my video. Please subscribe me, and you're going to know in the coming videos. Scalable. Airflow is designed to scale with your infrastructure, from running on a single machine to a large distributed system. Robust scheduler. The scheduler can orchestrate complex workflows by executing tasks in a correct order, handling task dependencies, and retries in case of a failure. Web-based UI. Airflow comes with a user-friendly web-based interface to manage and monitor workflows, view logs, and the troubleshooting issues. Also, they provide rich integration. Airflow integrates with various data processing platforms, cloud providers, and third-party services like AWS, Google Cloud Platform, Azure, Hadoop, Spark, and so on. Task monitoring. So task monitoring Airflow provides real-time task monitoring and alerting, allow the users to quickly identify and resolve issues in workflow. What's that mean? So Apache Airflow, they have the task status. So the task status, the monitor tasks in variable states, such like running status, success, failed, skipped, up for retry, queued, upstream failed, and up for reschedule. Also, they provide color-coded indicator. So we are able to see, each of these status, they have different colors. Also, they have the logs and output. So they have the task logs, and they also can provide log label. All right. So the Airflow also provides the alerts and the notification. For instance, the email alert and the Slack and another integration. So like I say, if you want to know more about email alerts, and the Slack integration, so just keep watching. Please subscribe me. All right. Then next step, I'm going to talk about the use case of the Apache Airflow. Data engineering. Data engineering, building and maintaining data pipelines for ETL, aka extract, transform, load processes. Manage data workflow across multiple data sources and distllations. Data science. So data science automatically machine learning pipelines, including data reprocessing, model training, and the deployment. Also the scheduling and orchestrating experiments and the simulations. This one is DevOps. So DevOps, they are automatically infrastructure provisioning and the deployment process. Collaborating complex system update and the maintenance task. Next one is business intelligence. So business intelligence, which is the able to scheduling regular data extraction and reporting tasks, automating data aggregation and transforming for analysis. All right. So when we should use Airflow, even talk to you, so this benefits and the key features and also the use case, right? So the strengths of the Apache Airflow. So choosing the right workflow orchestration tool can significantly impact the efficiency and the effectiveness of your data processing needs. Apache Airflow is a popular choice, but it's important to understand its strengths and limitations. Compare with another technologies like Apache and Kafka, especially in scenarios involving real-time processing and large-scale data handling. So here I have some detailed comparison and guidelines on whether Airflow is ready for you. So batch processing. So best for scheduled task. Okay, so Airflow excels at orchestrating complex workflows where tasks needed to be executed in a specific order or unscheduled. It's ideal for lightly like ETL jobs, extract, transform, and load jobs, reporting generation, and the patch processing task. Flexible scheduling. Support cron-like scheduling, making it perfect for jobs that needed to run at regular intervals, like hourly, daily, weekly, monthly, right? So complex workflow. So dynamic DAGs, which allows the creation of dynamic DAGs that can adjust based on the runtime variables or conditions, offering flexibility for complex dependency. Extensive operator library, so which includes operators for variety of tasks, from a simple patch scripts to complex data transfers across multiple platforms. Ease of monitoring and management. They have a web interface, provide like I already mentioned, right? So the user-friendly web interface for visualization, DAGs, monitoring task process, and the troubleshooting. Log and not. So I will talk to, so I'm not going to talk to at this time. Integration with data ecosystem, supporting variable systems, iterative integration. So they support many systems. So they are very easily to integrate with like databases, cloud storages, big data processing framework like Hadoop and Spark. Custom cost extensions. So basically we are able to write down our custom operators and the hooks to extend the functionalities. All right. I will talk to the strengths of the Apache Airflow. See, right now I'm going to talk about what is the limitations of Apache Airflow. Okay, not for real-time processing, right? So because they have the legacy. Airflow, because Airflow is designed for batch processing and is not optimized for real-time data processing. Task execution is typically not instantaneous, and there can be delays due to scheduling and resource allocation. Overhead. The orchestration overhead and the dependency management can introduce legacy, make it unsuitable for taxes, and require immediate processing. Last one is scalability concern. Complexity at scale. See, managing a lot of the managing a large number of DAGs and the tasks can become complex and they may require additional resources and the training. Also, resource management. So they require very careful resource allocation and management to handle high volumes of the data and ensure efficiency execution. All right. So what is the, I actually would mention the use cases ideally for Apache Airflow. Okay. ELT pipelines, data warehousing. Okay, I want to talk to here is the data warehousing. So because we are able to, connect or integrate with the third-party databases like Snowflake, like Postgres, MySQL, etc. Okay, so and also others they are data warehouse. So they are able to integration with data warehouse, and also because they're scheduled and manage the periodic refresh of the data marts and warehouse. Machine learning pipeline. So machine learning pipeline, they provides automatic data reprocessing, model training and evaluate in batch model, report generation. So they schedule and generate, periodic reports for business integration. See, so there is Apache Airflow is able to, once you, process or generate or aggregate your data. So which is they are able, so those, results of in this table or in this. So this, this outcome after the generation and aggregation into a database. Those is the results which can shows up like Tableau or something else reporting for the business users to do the business analysis. All right. Okay, so next I want to talk is when to consider Kafka or another real-time processing tools. You might have some concern. Also, when the first time when I use Apache Airflow, I'm thinking about why I'm going to use Apache Airflow if there, what's the difference with the Kafka, right? Okay, so here is the things I want to talk to you about the Kafka. So strengths of the Apache Kafka. So Apache Kafka, they provide real-time data streaming. They have the low latency and the high throughput. So Kafka is designed for real-time data processing, allow the data to be ingested, processed, and analyzed with a minimal delay. See, they have the minimum delay. Comparison with Apache Airflow, because they have a scheduler, so that scheduler going to schedule your task to be executed, right? But they are not the real time. They may be delayed. Okay, but Kafka provide you with the minimum delay. So this is the bigger difference. So high throughput. Kafka is able to handle large of the volumes of the data, making it suitable for high volume of data streams. The difference, right? So we have the Apache Airflow. So you have to run the Apache Airflow in your, no matter what you're going to use. So you have the behind the scenes of your orchestration. No matter if you're going to use AWS EC2 or something Kubernetes, whatever. So you have the limited resources. They are limited by your orchestration EC2 or Kubernetes, right? So the difference here is Kafka provided by AWS. I'm going to talk about the AWS Kafka. Okay, so they provide you the big resources, so they're able to allow you to load bigger amount of the data. See, this is also the bigger difference, right? Okay, so scalability and the reliability. So distributed architecture. Kafka's distributed design provides high fault tolerance, ensure data is not lost and can be processed even if parts of the system failed. Partitioning. So the partitioning efficiently partition the data to distribute the load across multiple brokers and the consumers, allowed horizontal scaling. Okay, so that is why Apache Airflow, they have limitations of the scaling. Also, this one, event-driven architecture. Okay, so we have the asynchronized processing. See, here is actually Apache Airflow, we also support asynchronized processing. But it does not mean Apache Airflow is not suitable for event driving. But I would like to say, Apache Kafka is better and more suitable for asynchronous processing. Okay, so asynchronous processing, basically they are dependent on event driving architecture, right? So when the data is processed asynchronous, enable real-time data processing application, decoupling system. So decouple system means so they allow the decoupling of the data producer and the consumer, making it easier to build a scalable and the maintenance system. So if you have any concern, please leave your comments. I will explain to you with detail, right? Okay, so no matter which system or applications or services you are going to choose, they still have their limitations. So I'm going to talking about the limitation of the Apache Kafka. Complexity. So the complexity have the setup and the management, also non-code. Setup and the management. Setup, the Kafka, they requires a significant amount of setup and the configurations. So when we try to set up the Apache Kafka, which requires a significant amount of the setup and the configuration, and then managing a Kafka cluster can be complex. So here I'm not going to talking about, AWS also they provide the Kafka. I'm talking about the Apache Kafka in here. I apologize. I know sometimes I'm going to talk about the AWS Kafka, and right now I'm going to talk about I'm going to talk about Apache Kafka. All right. So learning curve. Steeper learning curve comprised to a batch or steeper learning Kafka compared to batch-oriented tools like Airflow, specifically for teams unfamiliar with event-driven architecture. So they're going to have the learning curve. Okay. All right. Not ideal for complex task dependency. So they have the limitations of the orchestration. So while Kafka excels at streaming data, it doesn't provide the same level of task orchestration and the deployment and dependency management as Airflow. And so see, what use cases Kafka I'm able to use? So real-time analysis. Real-time analysis, they're able to analyze streaming data in real time for insights and decision-making, log aggregation, collect and aggregate logs from various systems for monitoring and analysis. So see here, if you understand what is event driving, so if you have applications, no matter it's web applications or desktop whatever, so anytime if they have any logs, so basically you have the you have the user interface. They are able to generate the logs. The backend they also generate logs. See how many if it depends. See here it depends on the users, right? How many users do you have? So they're going to generate amount of the logs. Okay, so at this time, Airflow might not be suitable because they have too many logs, and we want to access that in the real time. Okay, so this is not suitable for Airflow. Instead of should we choose a Kafka, right? Okay, next one, event drive. Okay, see, I'm talking about event driving. See, I'm not going to talking again. See, here you want to really understand the Kafka, Apache Kafka, okay? Just to, leave your comments. I will explain to you. The last one is data integration. So data integration is they have the streaming data across different systems and the platforms in the real time for seamless integration. So see here is the benefits or the use cases, which is you are able to use Apache Kafka. All right. So in this table, I write this table and this table and provide the summarize each of the features and regarding the Apache Airflow or Apache Kafka. And you are going to think about, so see here is a good time for you to think about Apache Airflow or Apache Kafka, which one is suitable for you. If you want to have the data pipeline, right? See? So when to choose Apache Airflow? If you have the patch processing needs, if you, primarily need is to orchestrate complex workflows that runs on a schedule or in a patch model, Airflow is an extended choice. Okay, so complex dependence. Airflow is ideal for tasks that have complex dependencies and need to be executed in a specific order. Ease of monitoring. Because of Apache Airflow, they provide user-friendly web UI, and also they provide the extensive logging, making it easier to monitor and troubleshoot workflow. Integration with another data pipeline. If you are building data pipelines that involves data extraction, transforming, and loading, Airflow's integration make it a suitable option. When you should consider Apache Kafka or another real-time tool. So if your use case requires real-time data processing with minimal legacy, Kafka is the better choice. Even the driving architecture for applications that rely on even the driving processing, Kafka provides the necessary tools and scalability. Okay, see, even the driving, right? Because Airflow is able to, be triggered by even the driving. Okay, but there are another means they are able to accept not amount of the event driving event that goes in the payload, to your services, right? So Airflow, they have limitations for the scalability, but the Kafka here they are much better if you have a lot of event driving at the same time. high throughput requirements. Kafka able to handle large volumes of the data makes it suitable for high volume data streams. Okay, so let me give you a summarize. Apache Airflow, if you have the data pipeline, which they have dependencies. So they have upstream, and they need to make sure the upstream job tasks finished, then trigger another job, and then trigger another job, right? So you have to use Apache Airflow. So if you are going to deal with the big amount of the data or the payloads from the upstream or sent by the event at this time, so should be use Apache Kafka. Okay. Last one. Combining Airflow and Kafka. Actually, so for many organizations, a combination of Apache Airflow and Apache Airflow, a combination of Apache Airflow and Apache Kafka may be the best solution. You can use Kafka for real-time data ingestion and processing while using Airflow to manage batch job, complexity dependencies, and the pipeline orchestration. The hybrid approach leverages the strengths of both tools, providing a comprehensive data processing and the orchestration solution. All right, guys. So I think right now you already have the choice whether you're going to choose Apache Airflow or Apache Kafka. Maybe you want to have the combinations of the Apache Airflow and the Apache Kafka, right? So thank you for the watching. I will see you in the next video.